Right, let's do this same problem now, but using this more elegant approach of splitting the middle term. Alright, so remember what the basic idea is. We need to spot two numbers, m and n, which do something very specific. So we need m and n such that what? Well, m times n has to be equal to a times c. So that's 2 times minus 2 here, that's equal to minus 4. Okay. Next, what do we need? We need their sum to be equal to the middle term, because we're going to split the middle term. So m plus n has to be equal to minus 3. So this is where there's kind of skill involved, isn't there? Right? How am I going to do this? So you need to find two numbers. There's no guarantee you can do this, right? It's something important to understand. First of all, maybe the polynomial doesn't have a factorization. Then there's no way to do this, right? Not in the world of real numbers. And even then, there could be a way to do it in the world of real numbers, but it could be terribly difficult to spot the factorization. So this is elegant, but it's going to require kind of hopefully looking at small integers and finding one that works. So what do I think? Well, if I factor 4, I've got kind of two obvious options, 1 and 4 or 2 and 2. And I've got to have negatives, right? So I'm going to have one of those two terms as negative. So I think after a little bit of practice, so this is what I would do if I was doing this. I would kind of just check through the possibles at the factorization. So I would kind of think, okay, what have we got? We've got kind of 1 minus 4, that would work. Or we could have minus 1 and 4, that would work. I suppose we've got 2 and minus 2. So those are kind of the obvious choices when it comes down to it. There's infinitely many, of course. These are just the ones which are kind of whole numbers. Do any of these work? Well, certainly this doesn't feel right because the sum is 0. That's no good. But this guy, these two look pretty good. The second one doesn't work because the sum is equal to 3. The first one does because the sum is equal to minus 3. It's exactly what I want. So after a bit of trial and error, we come to the conclusion, well, let's have m. It doesn't matter really which way around we do it. Let's have m is equal to 1, and let's have n is equal to minus 4. Okay, so this is kind of trial and error. This is the problem with this method, right? It could be very hard to spot this. This is why the systematic approach is something you should absolutely know in case this doesn't work. So then what do we do? Well, I take my expression, my polynomial, and I rewrite the middle term as kind of a sum and a difference. Is that what I'm going to do? Yeah. Or I'm going to rewrite it as m plus n. So this is going to be equal to 2x squared. Okay, so plus x minus 4x minus 2. Okay, so then what do I do? Well, I kind of bunch my terms together. So these are going to kind of bunch together, and these are going to bunch together. And then I kind of factor things out to see what happens. So in the first expression, what do I see? I can pull a factor of x out. X, so I've got 2x plus 1 here. Is that right? The second expression, I can pull a factor of 2 out. So it'd be minus 2, 2x plus 1. Does that make sense? I'm being a little bit careful here. I'm turning it into a bracket. That's why the plus there, right? I need a minus, so that has to be a plus. Okay, so then what? Well, I've got the same factor. So finally, what do I have? I'll bring out the 2x plus 1, and I'm left with x minus 2 when it comes down to it, which is exactly the same as the previous example, except not done systematically. So this is kind of a nice method. It's good to get practice in it because it's terribly useful. And again, something that's really good about this method is it doesn't rely on a being equal to 1. I think many of you will have learned in high school how to do this with kind of a 1 there. And you'll have kind of a method very similar to this, but this will always work. This is kind of a generalization of that method, which is extremely useful.